Okay, so we're going to talk about endurance over these next few slides. This is a relatively short, straightforward lecture, so that's always a good way to start off a week. So, two main outcomes for today. So, muscular cardiorespiratory endurance and then VO2 max. All right, so what is muscular endurance? And simply put, muscular endurance is the ability of a muscle to resist fatigue. Now, we talked about fatigue last week. And so we just want to, how long can your muscle keep going? How long can it keep maintaining the level of power or the output that it's doing? Okay, so that's muscular endurance. Now, cardiorespiratory endurance is something that's related, but it's a little bit different. So according to the textbook, cardiorespiratory endurance is just the ability of the body to sustain exercise. So there's an argument to be made here that muscular and cardiorespiratory endurance go hand in hand. Okay, and so after I finish this video, when I go run today, right, I'll be able to see what my cardiorespiratory endurance is based on how long I run, how well it goes, that sort of thing. Now this leads us into VO2 max. Now VO2 max, I know that you guys did during week 9 of the semester, so this is a couple weeks later. And so VO2 max, remember VO2 is how much oxygen are you using? So VO2 max is the maximum amount of oxygen that you're using, and it's a measure of maximal aerobic capacity. Okay, now VO2 max is dependent on a couple of things. One of those is cardiac output. So your heart your cardiovascular system, I should say, can only deliver so much blood, and within that blood, there's only so much oxygen. Okay, and it's also dependent on how much oxygen are you actually able to take up into the muscles. All right, and so as you are aware, you've talked about this in lab, we've mentioned it a little bit in lecture, that as your exercise intensity increases, that causes your oxygen consumption to also increase. Okay, now with VO2 max, there's a max. So we reach a plateau where you can't go anymore. You can't use more oxygen than whatever your max is. Now, as you train, and that's what we're talking about this week, as we do aerobic training specifically, that's going to increase your VO2 max because one of two things, or both things are happening. One, you're increasing your delivery. In other words, you're increasing your maximal cardiac output, or you're increasing the amount that you're actually able to use. And this is more on a muscular level. Okay. Now, it's important to know that your oxygen requirement for a given intensity does not change. So regardless of whether or not you're fit or unfit, all other things being equal, it will require me to use a specific amount of oxygen to go run an 8-minute mile. Okay. It doesn't matter who I am or how trained I am, it will require a specific amount. All right. And so we can see that from this figure here. So if you look on the x-axis, we've got speed. So just think of that as intensity. On the y-axis, we've got relative VO2 max. And so blue line is pre-training, red line is post-training. Now, if you notice, in both cases, that if we're running at, or this person's running at 10 kilometers an hour, their VO2 is about 36, 37, somewhere in there. The only thing that changes is the pre-training, they hit their VO2 max at a lower intensity. Whereas the trained people, they go a little bit longer, and so they have a high VO2 max. They're almost getting up to 60. And so aerobic training increases that submaximal VO2, but the oxygen requirement is the same. And so basically what we're trying to say is that for a given intensity, your heart rate is lower. Okay? And so really what we're saying is that aerobic training decreases the relative oxygen requirement. And so if you take your VO2, let's say your max VO2 is, in this case, 60, well, now to run at 10 kilometers an hour, that's only 50% of your max or thereabouts, whereas for this person, it's closer to 75%. Okay? And so by training, heart rate's lower for a given intensity, so that means we have more room to grow, so our max heart rate occurs at a higher workload. And as we go through this this week, we're going to talk about how that we can make adaptations to the cardiovascular, the muscular, and even the respiratory system, which will help increase VO2 max.